Today we are going to talk about U-substitution. Now, U-substitution is a little tricky when you first get started, but it is one of the most useful tools you can use when integrating. Let's talk first about when you're going to use U-substitution. And we'll start by looking at the example problem we're going to work out in a second here. If you look at this function, you see that it uses the chain rule, or there's a function inside of another function. When that's true, you know how to differentiate, but it's a little harder to integrate, and this is where U-substitution comes in handy. We can set the inner function equal to U, and that way we can just substitute back the original function when we're done integrating. Now, it's a little difficult to figure out what U should be, and the key to U-substitution is making sure you understand how whatever you set as U really plays out in the rest of your original problem. I'll show you what I mean with this problem we're about to do, which is a little tricky, but it'll really help you understand how this works. So let's start. If you look at this problem, we're going to find the integral of the square root of 1 plus x squared times x to the 5th dx. Now, it may not be immediately apparent, but the first thing I want to do is actually simplify this equation a little bit. So I'm just going to turn this into the integral of the square root of 1 plus x squared times x to the 4th times x dx. Now, a couple reasons for doing this. The first is that having an x dx is generally helpful, and that's pretty key to U-substitution. Not always, but this term generally comes in handy. The next is that, remember, we want to find a relationship between different terms in the problem. There's no apparent relationship between this term and this term. And while that may also be true of this, you'll see in a little bit how this is simpler and easier to plug U in for. So now that we have our equation rewritten, let's find something as a value for U. Since this is our inner function, 1 plus x squared, I'm going to set U equal to 1 plus x squared. And then, to find du, we will simply take the derivative of that, which is going to be 2x dx. Now let's look back at our original problem for a minute. There's no 2x dx in this, but remember, now we have an x dx, and it's really easy to turn this quantity into x dx, and we're going to do that by setting du equal to x dx by dividing both sides by 2. Awesome. Now we have two terms, u and du over 2, that we can plug back into our equation to substitute and simplify. So let's do that. We're going to rewrite the integral as the integral of the square root of u times x to the 4th times du over 2. A couple of things to notice. The first is that du over 2 is actually just du times 1/2. And since 1/2 is a constant, in the next step we're going to be sure to pull it out and put it in front of our integral. And remember to multiply it by our integral when we get there later. Now the next thing is that we still have an x to the 4th. What are we supposed to do with this? This is where you have to be really plugged into U-substitution and understand how this term relates to everything in the original problem. So let's think about it. What in here could line up with something here? Well, since we can set either of these terms in terms of u, we can potentially make x squared u minus 1. And since x to the 4th is really just x squared squared, then this is just u minus 1 squared. So if we set x squared equal to u minus 1, we can rewrite this equation, and remember we're going to pull out the 1/2 this time, to equal 1/2 the integral of the square root of u times u minus 1 squared du. Awesome. Now everything is in terms of u. But before we integrate, we want to simplify. I'm going to do that in two ways. And the first is to expand this term, and the second will be to multiply by this. So I'm going to do that now. Don't forget your 1/2. It's really easy to do that, but it's important to getting the correct answer. So our next step, it's going to be 1/2 the integral of u to the 1/2. And I'm going to write it that way now, and I'll talk about why in a second. Times u squared minus 2u plus 1 du. Now we're going to multiply this out. The reason I make u to the 1/2 equivalent to the square root of u is because this will make multiplying a lot easier. If you think back to exponents and multiplying them, remember that exponents with the same base can just be multiplied together by adding up the total of their exponents. So if we think of this as 4/2, this is 2/2, then this will just become u to the 5/2, and this will become u to the 3/2. So we'll do that now. Our integral is now 1/2 the integral of u to the 5/2 minus 2u to the 3/2. Not a very good 3. And lastly, plus u to the 1/2 du. That's as simple as it's going to get, and now we can take our integral. Remember, you want to keep the 1/2 out in front, so we're going to put that there. And now let's talk a little bit about integration. We're not going to completely review integration, but a really easy mistake to make is that since these are fractions, remember when integrating, it's u to the n plus 1 divided by n plus 1. Since you're dividing by whatever this turns out to be, remember you're going to have to reverse the denominator and the numerator because you're dividing them instead of multiplying them. So while it's very intuitive to write 7/2, this is actually going to be 2 over 7 times u to the 7/2. Just be careful about that. It's a really easy mistake to make. Let's do our next term. I'm going to keep the -2 separate for now, so it's -2 times 2/5 u to the 5/2, and our last term is going to be plus 2/3 u to the 3/2. And remember, since we are integrating, we have to account for constant, and that is represented by the letter c. Alright, now there are 2 more things to do before we're done. The first is to multiply out this 1/2. However, because there are 2's in the numerators of all of these fractions, that's pretty easy to do in your head, so I'm just going to combine that step with actually plugging back in for u. So let's just remember that u equals 1 plus x squared. So we're going to substitute that back in to get our final answer. And you can just cross out the 2's now. Alright, let's do it. Our final answer will be 1/7 times 1 plus x squared raised to the 7/2 minus 2/3 1 plus x squared, that's 2/5 to the 5/2. And lastly, plus 1/3 1 plus x squared, all of that raised to 3/2. And don't forget your c. Alright, now that we've plugged back in for u, we have our final integral. That means that you really simplified the problem easily, and it was a lot easier to take that than to try to do it in its original format. So that's U-Substitution. And we're going to do just one more problem to make sure we have the hang of it. And I'm just going to clear the screen. Alright, the last problem we're going to look at is to find the integral of 1 over x squared minus 6 2x dx. And this one's a little simpler, but you can apply the same things you already learned. So let's see, what can we make u? Well, we have 2 functions, 1 over this and this. So we're going to make u our smaller function, which means u is equal to 2x minus 6. We take the derivative of that, and x squared. du will equal 2x dx. Let's look back at our original equation, and we have a 2x dx, which will make things very easy, so we can just plug in for du. And now we have the integral of 1 over u du. If you remember all of your integrals, you'll know that the integral of 1 over u is actually just the natural log of u, so our answer will come out to be the natural log of the absolute value of u plus c. This one's really easy because we just plug back in for u. We recall that u equals x squared minus 6. All of that plus c. And we have our answer. And that's how you do U-Substitution. It takes a little getting used to, but with practice it becomes very easy, and it's one of the most useful things you'll learn about integrating functions.